In this session, we shall discuss how to obtain the rank of the matrix by reducing it to echelon form or reduced row echelon form. Let us look at the first example. Determine the rank of the matrix by reducing it to echelon form. So first of all, how does the echelon form of the matrix look? What are the properties of echelon form of a matrix? In echelon form of a matrix, all the entries below the leading entry must be 0 and the number of zeros appearing before the leading entry must be greater than that in the previous row. So when you look at this matrix, the leading entry in the first row is -1 and all the entries below -1 must be made 0. So I need to apply the transformations R2 plus 2R1 so that 2 minus 2 gives you 0. I need to apply this transformation R3 plus 3R1 so that 3 minus 3 gives you 0. And the other transformation is R4 plus 5R1 so that I get 5 minus 5 times 1. That is 5 minus 5 gives you 0. The remaining entries in the second, third and the fourth rows simultaneously change according to the row transformation. So we get this particular matrix. We have got the entries below the leading entry as zeros. Now when you observe carefully, the last two rows are identical. I can make them 0 by subtracting the fourth row with the third row, or another way of making the last two rows 0 is the third row and the fourth row are the elements of the third row and the fourth row are 2 times that of the elements of the second row. So I can apply the transformations R3 transforming to R3 minus 2 times of R2, and other transformation would be R4 transforming to R4 minus 2 times of R2. So when I apply this particular transformation, I get this particular matrix where I have 2 0 rows at the bottom. So always the 0 rows must be placed at the bottom or must be placed below the non-zero rows. So this particular matrix is in row echelon form since the leading and all the entries below the leading entry are zeros. So the leading entry in the first row is -1 and all the entries below -1 are zeros. The leading entry in the second row is -1 and all the entries below -1 are zeros. So this satisfies the properties of echelon form of the matrix. So the number of non-zero rows in this particular matrix is 2. So the rank of the matrix is equal to 2. Let us look at another example. Reduce the matrix to echelon form and hence find the rank. This is a rectangular matrix again of order 4 cross 3. So when you look at this particular matrix, the leading entry in the first row is 1, the leading entry in the second row is 1, the leading entry in the third row is 2, the leading entry in the fourth row is 3. So you have a 0 before the leading entry in the first row. So in the first row, you have a 0 before the leading entry. The number of zeros appearing before the leading entry must always be greater than that in the previous row. But here you have 1 0 before the leading entry. There is no 0 before this leading entry, which violates the property of echelon form. So what we do is we interchange the first and the second row. So when we interchange the first and second row which contains the elements 1 to 1 now becomes the first row, and the elements of the original matrix which are in the first row now go to the second row. The third and the fourth row remain unchanged. Now this is the leading entry in my first row, and the entries below 1 must be made 0. So 2 must be made 0 and 3 must be made 0. So I apply the transformations. 2 is lying in the third row, so R3 transforming to R3 minus 2 times of R1, and the other transformation would be R4 transforming to R4 minus 3 times of R1. So when I apply this particular transformation, we get this resultant matrix. So again here the last two rows are identical. I can make the last row completely 0 by subtracting it with the third row. So when I subtract it with the third row, my equivalent matrix would be 1, 2, 1, 0, 1, 2, 0, minus 1, 3, 0, 0, 0. So this would be the matrix when I subtract the fourth row with the third row. The leading entry in the first row is 1 and all the entries below 1 are made zeros here. It's true. And the leading entry in the second row is 1 and the entries below 1 here should be made 0. So this minus 1 should be made 0. So how do we apply the transformation? So since this minus 1 is in the third row, I need to apply the transformation R3 plus R2. So when I apply this R3 plus R2, we get minus 1 plus 1 as 0 as well. So this particular matrix is in echelon form since all the entries below the leading entry is 0, since the leading entry of the first row is 1 and all the entries below 1 are zeros. The leading entry in the second row is 1 and all the entries below 1 is also 0. The leading entry in the third row is 5 and the entry below 5 is also 0. This is in row echelon form or echelon form. So the number of non-zero rows in this matrix is 3. So the rank of the given matrix is 3. Let us look at an example how to reduce a matrix to RREF, that is reduced row echelon form, and hence to obtain its rank. So this is again a rectangular matrix of order 3 cross 4. In a reduced row echelon form of a matrix, all the elements above and below the leading entry must be made 0 and the leading entry in each row must be unity. So now when you look at the first row, the leading entry is 1 and all the entries below 1 must be made 0. So this 3 must be made 0 and 1 must be made 0. So I can apply the transformations R2 minus 3R1 and R3 minus R1. So when I apply these transformations, these two elements become 0 and simultaneously the remaining elements also change according to the transformation applied. If you observe carefully, the third row that is minus 2 is 1 by 3 times of minus 6. So we can apply the transformation R3 transforming to R3 minus 1 by 3 times of R2. So when I apply this transformation, I have minus 2 here, minus 1 by 3 here. R2, the corresponding element in R2 is minus 6. So minus into minus gives you plus. So I get minus 2 plus 6 by 3, which is minus 2 plus 2, which gives you 0. So this transformation has been applied here. And in RREF, the leading entry in each row must be unity, that is 1. So the leading entry in the first row is 1, that's not a problem. But the leading entry in the second row is minus 6. So this minus 6 must be changed to 1 by dividing it by the same element. So when I divide minus 6 by minus 6, I'll get 1. So minus 6 is in the second row, so I'll apply the transformation R2 transforming to minus 1 by 6 times of R2. So this minus 6 has now become plus 1. But still, this is not in RREF, because in RREF, all the elements above as well as below the leading entry must be made 0. You have a non-zero entry above 1 that should be made 0. How can I make it 0? This 3 lies in the first row. So when I subtract it with 3 times of R2, we get 3 minus 3 times of 1, which gives you 0. So I need to apply the transformation r1 minus 3 times of r2. So this 3 has now become 0. So this particular matrix is in RREF, that is reduced row echelon form. The number of non-zero rows is 2, hence the rank is 2. Thank you.